All right, hey guys, I'm gonna take my mask off since no one else is in the room. But today, what we're going to be doing is looking at some example problems, and this is for section 1.2. So we're going to be looking at transformations. We're going to be looking at parent functions. So let's jump right into it. For these first few problems, all we're supposed to do is just identify the function family. So we can see for number one, this one definitely looks like a linear function because it's a straight line. So we can just write on there that this one is linear. For number two, that one's also a straight line, but it's horizontal. So it's specifically the constant function, constant. And you can just look at the general shapes, and they're going to tell you what the function family is. All right, so linear anytime it's a straight line, anytime it's a horizontal straight line, that's specifically a constant function. Number three looks like that V shape, so this is going to be absolute value. So absolute value. And then number four, you got that parabola, that U shape, so that one is a quadratic function. All right. So just being able to determine which, which shape goes with which function family, that's an important skill. All right, let's scroll down and look at what's next here. So in these exercises, we're supposed to graph the function, and then we're supposed to describe the transformation. So what I'm going to do in the first three is I'm just going to graph them, and then with the last three, we're going to describe the transformations. That way it can just kind of give you more examples and give you a few different things. So when it comes to graphing functions, you can use a graphing calculator. So one graphing calculator that I like is called Desmos. And so you can download it on your phone there to use at home, or if you have a TI-83, TI-84, something like that, you could use that as well. But then you just kind of plug in whatever the rule is. So for this one, we're going to plug in x minus 7. And if you do that, you should get a vertical line, not vertical, an angled line, right about negative 7. So it should come right through here. So you should have a line that looks right like that because it's a linear function. Okay, for number 6, this looks like it's a constant function. And again, if you graph it, then you see that you should get something that looks like that, a horizontal line right down there at negative 9. Number 7, this one's going to be an absolute value function, so it's going to look like a V, and it looks like it shifted up 1, so that's plus 2, so it's going to intercept right about in here. So it should be just kind of a V shape right in there, not right at the origin, because of the plus 1 right here. So that plus 1 shifts it up just a little bit. Okay, looking at the next few examples, we're just going to describe these transformations, so we're not necessarily going to graph them. We can see for number 8 that the only thing that was added on there is that minus sign. And that minus sign right there means that we're going to have a reflection. So you can just write in there that this is just a reflection. All right. For number 9, we see this 1/8 out front. That 1/8 out front is going to mean that we are going to have a stretch, or I'm sorry, a shrink. All right. So anytime you have a fraction less than 1, that's going to be considered a shrink. And so we can write that in there, shrink. We have a shrink there for number 9. All right, shrink by a factor of 1/8. Number 10, notice that we have a 6 out front, so that's going to be a stretch. A stretch. All right, so anytime you have a number less than 1, we're going to call that a shrink, or I should say less than 1 greater than 0. A shrink, and then anything greater than 1 we'll call a stretch. All right, let's look down at these next few. So number 11 says, identify the function family for this function and describe the domain and range using graphing calculator to verify your answer. All right, we can see very clearly in this equation right here that we have the absolute value bars right in there around the x, which means that the function family is definitely going to be absolute value. All right, so absolute value for that function. And then it also says describe the domain and range. So we can see that this function is going to be shifted upward 4 units. So if we did like a little diagram over here, we'd know right about at 4, we're going to have our V shape. But then also notice that we have a negative sign, which means that it's going to be inverted. So we're going to have an inverted absolute value function there. And then also the 1/3 means that it's going to be shrunk. All right. Which isn't really going to affect our domain and range. So we can write at this point that our domain, it looks like it goes to the right and to the left forever. So we can write our domain, I'll put it over here, domain is going to be all real numbers. Okay. And our range, and we're running out of space here, but our range is going to, looks like the maximum value is going to be 4, and then it's going to be everything smaller than that. So we can write, tell you what, just erase this, and we'll put our range right in here. Okay, our range is going to be y less than or equal to 4. Okay, so all the y values smaller than 4, and it continues down forever. Okay, let's look at number 12 now, and I just realized that I may have drawn that graph over my face, so let me show you the graph I drew real quickly. So hopefully this isn't on my face now, sorry about that. But you can see this was the graph right here, the little sketch that I drew. So we moved it up 4, and we inverted it, flipped it upside down. And so that's where I was getting my domain range. So sorry about that if that was covering up my face there. All right, let's move on to number 12. Number 12, the table shows the distance a bike rider or a bike rides in his first team relay competition, and asks us what type of function can you use to model the data. Best thing to do, guys, is that this is a data table. Just take it and kind of sketch out a plot. And if you do that, what you'll get is 4 data points, and you'll get something like this. So you'll get little data points that kind of track upwards. So if you were to do a best fit kind of shape for these dots, that would definitely be a linear function. All right, so linear function is what we're going to get if we graph this data up here. Next thing asks us, if the biker's teammate rides at the same pace but leaves an hour later, what type of transformation does that represent? So what we're doing is we're bumping up our time. So our time is going to go from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So essentially, we shifted our time over 1 hour. And if we look at that, what kind of shift is that? Well, our time is in the x coordinate. So x represents our horizontal. So this is simply going to be a horizontal shift. So we can write that in there. This is just going to be a horizontal shift. All right, guys, I hope that helps you out and gives you a little bit of information. If you have any questions, always feel free to ask. And thanks for watching, and I'll catch you on the next video.